Hello, good day. Sir Alex here. In this video, we are going to learn about the properties of parallelograms. Let us begin with the end in mind. At the end of this lesson, you are able to identify quadrilaterals that are parallelograms. Second, you are able to determine the conditions that make a quadrilateral a parallelogram. And lastly, you are able to use properties to find measures of angles, sides, and other quantities involving parallelograms. But what is a parallelogram? The dictionary definition of the word means quadrilateral whose opposite sides are parallel and equal. The history of the name came from the Greek word parallelogramon, which means bounded by parallel lines. The Greek word is formed by the root parallelos plus the stem of graphene, which means to write parallel lines or sides. Now, we know the origin of the name, but how do we name a parallelogram? Parallelograms come on different sizes and dimensions. We need to name them to distinguish each from one another. There are certain rules we must follow in naming a parallelogram. The four vertices of a parallelogram is used in naming the polygon. Any of the four vertex may be chosen in naming it, but in completing the name, you can only continue either in clockwise or counterclockwise direction. Let us take, for example, this figure. We have parallelogram ABCD. It has four sides, four vertices, and four angles. We can also name it BADC or CBAD or DCBA. But note that in naming a parallelogram, the letters must be in order corresponding to the positions of the vertices. You cannot name this particular figure as parallelogram ACDB, and you cannot also name this parallelogram as BDCA. You must start from a certain vertex and rotate in either clockwise or counterclockwise direction. But wait, how can we be sure that this quadrilateral is indeed a polygon? Well, there are conditions that should be met in order for us to be sure and for us to confirm that this quadrilateral is indeed a parallelogram. This condition states that if both pairs of opposite sides are congruent, then it is a parallelogram. In this example, we are given two pairs of opposite sides, side CA and side RE. Side CA is congruent to side RE. For the second pair, we have side CE and side AR. Side CE is congruent to side AR. The two pairs of opposite sides are congruent. Therefore, quadrilateral CARE is a parallelogram. For the second condition, if both pairs of opposite angles are congruent, then it is a parallelogram. We have here quadrilateral LM and O. We are given two pairs of angles, angle M and angle O. As you can see, they are opposite angles. We have here the symbol for congruence. Angle M is congruent to angle O. It is already shown that these opposite angles are congruent. Therefore, this rhombus is a parallelogram. For our third condition, if both pairs of consecutive angles are supplementary, then it is a parallelogram. We have here figure MATH. Two pairs of consecutive angles are given. The measure of angle M and the measure of angle A has the sum of 180 degrees. At the same time, the measure of angle H and the measure of angle T has also the sum of 180 degrees. These two pairs of consecutive angles both have the sum of 180 degrees. Therefore, this quadrilateral is a parallelogram. For the fourth condition, if both of the diagonals bisect each other, then it is a parallelogram. We have here figure LEAD. We are given two pairs of line segments. These line segments are formed when the two diagonals intersect each other, but we are going to find out if they are indeed bisecting each other. If two diagonals bisect each other, two equal or congruent line segments are formed. These two line segments have equal measure. For diagonal LA, we have line segment LX and line segment AX. Line segment LX is congruent to line segment AX. For the second pair, we have line segment EX and line segment DX. Line segment EX is congruent to line segment DX. Hence, both of the diagonals bisect each other, and we can conclude that this figure, this quadrilateral, is a parallelogram. For our fifth condition, if both of the diagonals divides the quadrilateral into two congruent triangles, then it is a parallelogram. Diagonal IE bisects quadrilateral GIBE into two congruent triangles. The two congruent triangles formed are triangle IBE and triangle EGI. Triangle IBE is congruent to triangle EGI. Hence, it is shown that two congruent triangles are formed in this quadrilateral. Therefore, it is a parallelogram. For the sixth condition, if one pair of opposite sides are congruent and parallel, then the given quadrilateral is a parallelogram. Side HL is congruent to side AE. At the same time, it is also shown in the figure that these sides are parallel. Hence, this quadrilateral is a parallelogram. Those are the 6 conditions that guarantee that a quadrilateral is a parallelogram. Let us review all of them one by one. First, both pairs of opposite sides are congruent. Second, both pairs of opposite angles are congruent. Third, both pairs of consecutive angles are supplementary. Fourth, diagonals bisect each other. Fifth, each diagonal divides a parallelogram into two congruent triangles. And lastly, one pair of opposite sides are congruent and parallel. From these conditions will arise the different properties that are present in a parallelogram. These 5 properties are as follows. Any two opposite sides are congruent. Any two opposite angles are congruent. Any two consecutive angles are supplementary. Any of the two diagonals bisect the other. And lastly, any of the two diagonals form two congruent triangles. Let us now try to use these properties to find measures of sides, angles, and other quantities involving parallelograms. Let us have a practice exercise. Quadrilateral MATH is a parallelogram. Letter A. Side MA is congruent to blank. Let us look for the side that is opposite side MA. In this figure, what is the side that is opposite MA? Yes, the side HT is the one congruent to side MA. So our answer to letter A is side HT. Letter B. Angle H is congruent to blank. What angle is opposite angle H? We have 3 other angles in this figure. Angle M, angle A, and angle T. It is clearly shown in the quadrilateral that angle A is the one opposite angle H. So our answer to letter B is angle A. Next, letter C. Triangle HMA is congruent to blank. Let us try to look for the other triangle that is congruent to triangle HMA. Diagonal HA is a side of triangle HMA, so it is only natural that side AH is also a side of the triangle congruent to the triangle HMA. So we will look for the triangle that has a side of diagonal AH. So what triangle has the diagonal AH as a side? Triangle ATH has the diagonal AH as its side. Therefore, we are looking for this triangle as the one congruent to triangle HMA. And it is our answer to letter C. Triangle ATH. Next, letter D. Line segment AS is congruent to blank. We will look for the other line segment congruent to side AS. In the figure, what is the line segment congruent to side AS? Observe that diagonal AH is being bisected by diagonal MT. And in the middle, the midpoint S is formed. So diagonal AH becomes the two line segments AS and the line segment HS. So the answer to letter D is line segment HS. And finally, we have letter E. The measure of angle M plus blank is equal to 180 degrees. We are going to look for the consecutive angle to angle M. In this figure, what is the consecutive angle of angle M? We have three other angles, angle A, angle D, and angle H. We are looking for, of these three angles, which one is consecutive to angle M? Angle A is the one consecutive to angle M. So answer is angle A. The measure of angle M plus the measure of angle A is equal to 180 degrees. Any two consecutive angles are supplementary. And now, we just used all 5 properties to look for the measures of angles, sides, and other quantities involving parallelogram. For our last activity, we have here a table. On the first column, different properties for quadrilaterals are shown. The last 3 columns are provided for each type of parallelogram. The second one is the column for rectangle. The third one is the column for square. And the last one is the column for rhombus. Let us start with the first property. All sides are congruent. Only the square and the rhombus qualify for this property. We all know that the perimeter of the square is 4s. All 4 sides are congruent. The same goes for rhombus, where all 4 parallel lines or all 4 parallel sides are congruent. The rectangle is a type of square where the length and the width have different measures, but it is not the same as the square and the rhombus, where all 4 sides are congruent. So in this row, for the first property, we will only put 2 check marks for the square and the rhombus. Second property, opposite sides are parallel. All 3 types of parallelograms qualify for this property. Going back to the definition of parallelogram, a parallelogram is a quadrilateral whose opposite sides are parallel and equal. Therefore, the rectangle, square, and rhombus all qualify for this property. For the third property, opposite sides are congruent. We will now proceed to put all 3 check marks for every type of parallelogram. We are now done with the properties concerning the sides of a parallelogram. Let us move on to the properties concerning the angles of the parallelogram. For the fourth property, it states that opposite angles are congruent. Which of these 3 types of parallelograms qualify for this property? Again, by the definition of parallelogram, all 3 types of parallelograms have opposite angles that are congruent. So all 3 types of parallelograms have check marks on them. For the fifth property, opposite angles are supplementary. The square and rectangle automatically qualify for this property. But what about a rhombus? We know that by looking at a rhombus, none of its four angles are 90 degrees. So if that's the case, the measure of opposite angles could be less than 90 degrees or more than 90 degrees. It will create acute or obtuse angles, and when acute angles are added or when obtuse angles are added, it will either exceed 180 degrees or be less than 180 degrees. So opposite angles in a rhombus will never be supplementary. Only the square and rectangle qualify for this property. For the sixth property, diagonals are congruent. In relation to the previous fifth property, the measures of a rhombus in relation to the previous property, acute angles and obtuse angles cause the diagonals in a rhombus to be either shorter or longer than the other. And in that case, the diagonals in a rhombus will not be congruent, so they do not qualify for this property. In that case, diagonals in a rhombus will never be congruent. So only the square and the rectangle, again, qualify for this property. For the seventh property, diagonals bisect each other. All three types of parallelograms qualify for this property. The rectangle, the square, and the rhombus all have diagonals that bisect each other. In a quadrilateral, when all four sides are parallel and congruent, it is automatically shown that the diagonals bisect each other. So in this row, all of them have check marks. For the eighth property, diagonals bisect opposite angles. The eighth property is a consequence of the seventh property. In a quadrilateral, when two diagonals bisect each other, the consequence will be that the opposite angles will be bisected into two congruent angles. So in this property, all of them qualify. For the ninth property, diagonals are perpendicular to each other. What do we mean, again, by the word perpendicular? When lines or sides are perpendicular, they meet at a certain point where they form a 90-degree angle. In a rectangle, as you can observe, the length could be infinitely longer than the width. We can extend the length of the rectangle as long and as much as we like. As a consequence, its diagonals can also get closer and closer to each other, forming acute angles. That is why, in a rectangle, diagonals will never be perpendicular to each other. In this property, only the square and the rhombus qualify. And lastly, for the 10th property, a diagonal divides a quadrilateral into two congruent triangles. As you can remember, this property is also a part of the condition. So if all of them, the rectangle, the square, and the rhombus, are parallelograms, automatically all of them qualify for this property. Before concluding our activity, let us first spot the major differences on each three types of parallelograms. On the first property, only the rectangle did not qualify. We know that the rhombus and the square has its all four sides congruent, and the rectangle has its own length and width. On the fifth and sixth property, only the rhombus did not qualify. The rhombus does not have 90 degrees angles, and by consequence, the opposite angles will never be supplementary, and the diagonals will never be congruent. One diagonal will be shorter or longer than the other. And lastly, only the rectangle again did not qualify for the ninth property. In a rectangle, the diagonals will never be perpendicular. Why? Because the length and the width will never have the same measure. And that ends our activity. It is my hope that you learned something today. Thank you for your time and see you in my next video.